Hello everybody. So let me jump into it. There are certain linguistic tools that I have to give to you so you can basically decipher this information. Okay, so there's basic information that I have to give you so you can understand how existence works fundamentally. Okay, so first of all, there is the torus, which is basically the infinite torus, okay? You can think of it as one of two ways. You can think of it as kind of like the Earth. Whenever you're a ways away from the Earth looking at it, it just looks like a particle, okay? But once you get close, you start to see all the waves and particles, which within the torus are basically infinite, okay? They keep on going. They don't stop. That's why it's called the infinite torus, okay? And then you have the photon, which is basically shooting out strength in infinite directions, okay? Then you have the boson, the Higgs boson, which is basically pulling in string from infinite directions, okay? And then you have the gluon, which is basically an infinite torus of both photons and Higgs bosons, okay? And contained within the photon is infinite photons and Higgs bosons. Contained within the Higgs boson is infinite photons and Higgs bosons, okay? Next, you have the gradiuses of space, okay? Gradius means step in Latin, okay? So the gradiuses of space you can think of like this. They're like the steps of space that never stop. They basically get infinitely smaller and infinitely larger, going every which direction, okay? Then you have fields of time, okay? For instance, right now, you and I are on a different field of time, okay? Because I've already recorded this video, put it on the internet, so you're actually watching the past right now, okay? We can watch the past, but we can only imagine the future, okay? That's the way that it works, okay? That's how we can watch films and have photography and all this different things like that, because you can only watch things that have happened in the past, okay? For instance, like you and I might only live to be 70 years old, you might live to be 80 years old, okay? So those are different fields of time, okay? For instance, a hummingbird, okay? A hummingbird, its heart rate is over 1,000 times per minute, okay? It's on a much faster field of time relative to me, okay? I also need to explain relativity a little bit, okay? So, relative to me, I'm here. Relative to this marker, it's here, okay? That's relativity. That's all relativity is, okay? I think that's the basic fundamentals of explaining things, okay? So let's get into tracing the string, okay? So basically, all the string is basically a series of Higgs bosons and photons getting infinitely larger and infinitely smaller, okay? That's all it basically is, okay? So within this Higgs boson in the middle, you have infinite photons. Within this photon on the next level, you have infinite Higgs bosons, okay? And it keeps going like that, infinitely, every which direction, okay? Because the photons are basically pushing out string infinitely, and the Higgs bosons are basically pulling in string infinitely, okay? So let me explain to you the difference in bosons, okay? So you have W plus bosons, W negative bosons, and Z bosons. Okay, so what is the difference between W negative, W positive, and Z bosons? Okay, well, I'll tell you right now. Z bosons are basically the horizon, okay? Whether it's the horizon of the Higgs boson or the horizon of the photon, okay? It's basically relativity at its fundamental level, okay? Because think about a star out in space, okay? So a star out in space is surrounded by infinite Higgs bosons, and there's photons within there as well, okay? But relative to the star, okay, the Higgs bosons on the outer edge of space, which never stops, it's infinite, but the Higgs bosons are as large as they can be. And relative to that star, by the time they get to its horizon, they're as small as they can be, okay? So what happens, and the photons relative to the star are as large as they can be, okay? So what happens after they reach the horizon of the star? Well, the Higgs bosons start to get larger again. Or the field of Higgs bosons begin to get larger again. Okay? Because this is all the Higgs field. Everything within this. Okay? But you have to look at it like the Higgs bosons getting smaller, photons getting larger, Higgs bosons getting larger, photons getting smaller. Okay? That's the way that it works. That's how all of existence fits together with everything. Okay? So the Z boson is basically the horizon. Okay? W positive bosons are basically the photons, the light that's being shot out by the photon. Okay? The W negative bosons are basically the Higgs bosons that are infinitely contracting, infinitely pulling the light in. Okay? That's how it works. It's basically just photons infinitely pushing out string, pushing out light. Higgs bosons infinitely pulling in string, pulling in light. Okay? Higgs bosons aren't necessarily dark. Okay? They're clear. Okay? But it just, whenever you look out in space, it appears dark because it goes so far out that it appears dark, but it's really clear. Okay? Just like the room in this, the air in this room is clear. Okay? So those are the bosons, okay? So gluons are basically just conglomerations of infinite photons and infinite Higgs bosons, okay? So if you want to look at it like a string, you basically just grab a string, you look in it, and you'll see infinite Higgs bosons, infinite photons, okay? So those are basically what gluons are, okay, as well. I know it gets kind of confusing because Higgs bosons are basically, one Higgs boson is basically a conglomeration of infinite Higgs bosons as well as infinite photons. A photon is an infinite conglomeration of photons as well as Higgs bosons. And a gluon is infinite conglomeration of Higgs bosons and photons, okay? But the building blocks are pretty much the photon and the Higgs bosons, okay? Basically, the Higgs bosons are what they refer to as the Higgs field, okay? It's everywhere, okay? It permeates all of existence, okay? So let's get into the gratis's a little bit more real fast. So like I said, with the gratis's, everything is basically the steps of space going in infinite directions, okay? So let me explain to you what that entails, okay? So that means that a Higgs boson is also electrons as well as black holes. Okay? A photon is also a proton as well as a star. Okay? And a gluon is a neutron, which is also a planet, moon, and asteroid. Okay? It's all the same thing. Okay? I know that it sounds trippy, but once you get past this part of it, it all starts to make sense, okay? The trippiest thing about it is you are here on a gluon, which is the Earth, okay? And we are basically revolving around the sun, which is a photon within space, which is Higgs boson within you. Okay? All that we're looking at whenever we look out into space is the fundamental particles. Okay? So let me explain that a little bit more. So you might say, well, whenever we look out into space, why do things appear flat? Like, why do galaxies appear flat? Okay? Well, I'll explain that to you right now, okay? Because we can only see within our field of time, okay? If we could see within all fields of time, existence wouldn't be able to exist, okay? Because you would just see everything at once, okay? So whenever you look at a galaxy, you know, you have the black hole in the middle, and then you have the stars, planets, moons, asteroids, all around the black hole, okay? So due to us only being able to see in our own field of time, it looks flat, but it's not really flat, okay? Because if you saw in all fields of time, it wouldn't be flat. It would be shaped like a sphere, okay? Because you would basically be able to see all the different fields of time. So instead of appearing flat, you would see all the different dimensions of it, okay? Which are infinite, okay? Shooting infinite directions, okay? Because we don't live in 3 dimensions, okay? We live in infinite dimensions, okay? Because they say, well, we live in 3 dimensions because length, width, and height, okay? But we really don't, because length goes every which direction, height goes every which direction, width goes every which direction, okay? We live in infinite dimensions, okay? We don't live in 3 dimensions. It's infinite dimensions, okay? But like I said before, you can only see within your own field of time. And that's why space, the things that you see out in space, like the galaxies and stuff like that, appear flat to us, okay? So let me get into tracing the string a little bit. Okay, so on the quantum level, the level of the fundamental photon and Higgs boson, you have waves, okay? So you can think of the Higgs boson as the beginning of the wave and the photon as the end of the wave, okay? And what do those two make up? A sphere, okay? And then what happens whenever you look into the sphere? You see infinite waves and infinite particles, kind of like looking at the Earth, okay? So on the photonic level, you have the beginning of, they call it the electromagnetic spectrum. I don't like to call it that. I like to call it the information spectrum, okay? Because that's what it is. It's information, okay? So at the beginning of the information spectrum, you have love waves, which oscillate at 10 to 0, okay? So what is 10 to 0? 10 to 0 equals 1, okay? But if you take 0, okay, so say you have 0, in 3 dimensions, 0 is 0, okay? But in infinite dimensions, spinning every which direction, 0 becomes a sphere. So, what does that mean? Well, that means the information spectrum starts at infinity, okay? For instance, me talking to you right now, okay? Starting from 0 is basically where a thought process comes into my mind, okay? And then, bam, infinitely, I shoot out my thought at you. That's what's happening right now, okay? All this is happening on an infinite level from every which direction, okay? It's all infinite, okay? That's another thing about it George Cantor came up with, was the idea of the infinity of the infinities, okay? That's exactly what it is. It's the infinity of the infinities, okay? But the way that you can kind of break it down is there's different degrees of infinity, okay? But even the degrees of infinity are infinite, okay? That's how infinite it is. But anyway, so you start out at love waves, which oscillate at 10 to the 0, and then you have radio waves, microwaves, infrared, light, ultraviolet, X-ray, gamma waves, and then you have entropy waves, okay? Which oscillate at what? 10 to 0, which is what? The same thing as 10 to infinity, okay? Because it's all infinite. The entire spectrum is infinite, okay? I'll get into that in just a little bit, all right? So love waves can be considered magnetic waves, which are basically pushing everything out. Okay? And entropy waves can be considered gravity waves, which are pulling everything in. Okay? That's how it all works on the fundamental level. Okay? So let me show you how exactly this all relates to me drawing this. Okay? So think of that little blue dot as a photon. Okay? So it's a blue photon. So you see it as blue light. Okay? But this photon is actually pushing out waves from the entire spectrum. Okay? So you have basically love, radio, microwave, infrared, and light. Okay, so the way that it works is the love waves are basically being shot out at you, okay? That's what you're actually seeing is the love waves, okay? But it's also shooting out radio, microwave, infrared, light, ultraviolet, X-ray, gamma waves, and entropy waves, okay? And how is that? Well, because love waves are basically what you can see, okay? So between that photon and you and I is basically an infinite Higgs field, okay? Full of photons, infinite photons, and infinite Higgs bosons, okay? So the love waves are what you see, okay? You can't, the light, the light waves are what you see, okay? But it's all being pushed out by love waves, okay? So the radio waves, the love waves are the biggest waves, okay? The ones that you can see, okay? The radio waves, microwaves, infrared that it's pushing out, you can't see, okay? But all those are basically getting bigger, okay? Because it's pushing out infrared, microwaves, radio waves, love waves, okay? Now, on this side of the spectrum, the waves get smaller, okay? So they're not getting bigger, they're getting smaller, okay? So ultraviolet is smaller than this photon, X-ray is smaller, gamma is smaller, and entropy is basically the smallest, okay? So that's the way that it works, okay? Basically, every single photon within existence is pushing out infinite love, radio, microwave, infrared, light, ultraviolet, X-ray, gamma waves, and entropy waves, okay? They're all being pushed out, okay? So that's how you can see everything, okay? That's how you can see light, okay? But due to relativity, if I walk back here, relative to me, that photon gets smaller, okay? Because relative to me, its photons are getting smaller. And the Higgs bosons are getting larger, okay? Whenever I go close to it, it appears larger because the photons relative to me are larger. And the Higgs bosons are smaller, okay? That's basically relativity, okay? So that's the string and how that pretty much works. I hope you guys can understand that because it's kind of a tricky thing. But yeah, just think about it like this. You know, the light is pushing out. Infrared gets larger. Microwave gets larger. Radio gets larger until love, which is what you're actually seeing pushed out at you, which is what's making the light, okay? And ultraviolet, X-ray, gamma, and entropy are what are getting smaller, okay? But the waves that are more or less kind of caustic to us, that are above light, don't affect you on this level because this gratis is so small relative to us. So these waves don't affect us, okay? Okay, so let me get into tracing the string of the atom, okay? So like I said, this is on the quantum level. This is the photonic level, okay? Is the most fundamental that it pretty much gets, okay? So on the next level, you have, okay, so let me just write these out real quick. So think about it like this, okay? Higgs boson, photon, Higgs boson, photon, Higgs boson, okay? So that's basically all it's doing, okay? With the photonic string infinitely expanding and the bosonic string infinitely contracting, okay? So, yeah, let me trace this real quick. Okay, so you have, on the first level, you have the okay, so you have, first of all, you have the Higgs boson, and then you have the photon. Okay, and both those together make what? The gluon. Okay, so then you have the electron antineutrino, electron neutrino, muon antineutrino, muon neutrino. Then you have the electron, the positron, the up quark, the anti-up quark, the up quark, the anti-down quark, the down quark, the tau antineutrino, the tau neutrino, anti-strange quark, the strange quark, the muon, the anti-muon, the muon. Okay, and then I have to go down here. You have the anti-charm, the charm, the anti-tau, the tau, the bottom quark, anti-bottom quark, the bottom quark, and then you have the anti-top quark and the top quark. Okay? And that's basically the string of the hydrogen atom. Okay? Because basically an electron is 3 down quarks. Okay? It's basically 3 negatives. Okay? And then you have the proton, which, like I said, is a photon, which is 2 up quarks and 1 down quark. Okay? And then you have the neutron, which is a gluon, which is 2 down quarks and 1 up quark. Okay? So that's basically tracing out the string of the hydrogen atom. Because at the end of the top quark starts the Higgs field again, which is what? Infinite photons and Higgs bosons, which make up what? Okay? So neutrinos are relatively very small, okay? And that's basically why, for the most part, they're closest to the photon, okay? I don't know the tau neutrino, if they have the mathematics perfectly correct with it or not, but for the most part, neutrinos are very, very small, okay? Which is why, for the most part, they're so close to the photon, okay? Because they're the first, basically, matter that's being shot out by the photon as well as pulled back in, okay? And then once you get up to the level of the quarks, they get to be fairly large, on the subatomic scale, okay? So let me make sure the video is doing okay. Yeah. Okay. So positive, negative. Okay, yeah. That was kind of throwing me for a loop because I said that the electron is 3 down quarks, which it is. And you might see more negatives than you see positives here, but the reason for that is because if you added up all the positive and the negative for the entire string of the hydrogen atom, it would be basically 0. Okay. But anyway, let's get into quantum theory and relativity. Okay. Okay, so relativity is basically E equals mc squared. Quantum theory is energy equals Planck's constant times frequency. Okay? So, in order for people to make things work, they have to use their imagination and basically come up with formulas and stuff like that to make things work, okay? And up until this point, this stuff has worked pretty well for us, okay? We've come up with all kinds of different technologies due to it, okay? But the thing about it is, both of these are arbitrary numbers, okay? They're just arbitrary. They're numbers that Einstein and Planck pulled out of nowhere to basically make things work, okay? So, energy equals mass times the speed of light squared, okay? You don't need it like that, okay? It should just be this. Energy equals matter, okay? And Planck's constant is 6.626 times 10 to the negative 34th, okay? This is just an arbitrary, really small number, okay? It used to basically make things work. You don't need to use that, okay? Because if you account for both particles and waves, everything is pretty much infinite, okay? It's all infinite. It's just all moving at different degrees of infinity, okay? But yeah, if you basically just apply these principles to the weak force, the strong force, the electromagnetic, and gravity, they all fit together because they're all the same thing, okay? Just in different gradiuses, okay? They're all the same thing though. Now, what exactly is dark matter and dark energy? Okay. Well, dark matter is pretty simple. Okay. Dark matter is basically where Higgs bosons and photons are in equilibrium. Okay? So, for all the infinite string being shot out by the photons, there's infinite string being pulled in by the Higgs bosons, okay? They're in equilibrium. That's what dark matter is, okay? Where things are in equilibrium, okay? For instance, in this room, okay? Things are in equilibrium, all right? Now, what is dark energy, okay? Well, I'll tell you. So, the middle of the galaxy, you have the black hole, and it's being orbited by stars, which are being orbited by planets, moons, and asteroids. Okay? So, like I said before, a photon is a proton and a star, okay? A Higgs boson is electrons and a black hole, okay? A gluon is a neutron as well as a planet, moon, and asteroid, okay? And Higgs bosons are also basically just space, okay? So, what happens whenever I drink this water, okay? Because what is this water? It's one hydrogen atom, or it's two hydrogen atoms and one oxygen atom, okay? So, relative to me right now, the spheres in this water are relatively large, okay? Now, as I drink the water and it goes into me, it goes into my GI system, think of it as spheres getting smaller and smaller and smaller, okay? So it goes into my GI system, it gets broken down, okay? So all these are being basically broken down, until they get to the level of what? The fundamental level of photons and Higgs bosons, okay? So they start to basically feed back in to my energy, okay? Which is what? Basically the galaxies, okay? Because that's the whole point with the gradiuses of space. You are the universe, okay? Do you understand that? You are the universe, okay? You are infinity, all right? But that's dark energy. That's all it is. It's basically just the... Because think of this as the infinite Higgs boson, the Higgs field, okay, which is space, and it's feeding back in, okay. It's feeding the photons, which are feeding the gluons, okay, and it's also feeding the Higgs bosons, okay. And what happens in the middle of the galaxy? Well, everything starts to basically go in reverse, okay? Because out here, everything is going forward. But to compensate for that, out here, everything is going backward, okay? Now, let's get into nuclear power real quick, okay? So, energy cannot be created or destroyed. It can only be converted. Okay? So, if you look at it like this, okay, so this is the center of a galaxy, okay? Basically the black hole. And around that black hole are relatively large stars. And they're filled with what? Well, they're filled with relatively large spaces of Higgs bosons, okay? Because the stars that are directly next to the black hole, well, what is their next level? Well, they're basically going to pop and become the black hole. Okay? So the farther out you get in the galaxy, the smaller the stars become. Okay? So, with nuclear power, they have something called a neutron initiator. Okay? So, a neutron initiator basically shoots out neutrons, okay? And they basically they have that wrong with nuclear energy. It's not necessarily due to the neutrons that are causing the fission. It's because the neutrons are basically think of this as a conglomeration of neutrons, okay? And they're basically shooting the neutrons at the photons. And what happens to the photons whenever they get shot out by the neutrons? Well, it's just like a big balloon, an expanded balloon, okay? They pop. Pop, 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 pop. And that's what causes a nuclear explosion, okay? It's you're not getting all that energy from neutrons necessarily. You're getting it from the photons basically popping. Okay? Because think about it like this, okay? A photon follows the same paradigm as the table of elements, okay? Ideally, they should probably change it from the table of elements to the table of photons, okay? Because out here, you basically have kind of like hydrogen photons. And as they get closer to the center, they become larger photons, okay? Which become more and more unstable the larger they get. Because not only are the photons growing, they're also, think of the sun, okay? As the sun expands, it's going to eventually absorb the gluons, which are the planets, moons, and asteroids, okay? Because it's going to be getting so large, okay? And the larger it gets, the more unstable it becomes, okay? So the easier it is to pop, okay? Which is why they use plutonium and uranium in nuclear bombs, because the photons are easier to pop because they're unstable, okay? And going back to the information spectrum, like I was talking about before, if you get up to the level where the photon is basically, okay, so say the photon is basically this large, relative to the information spectrum, okay? And outside of it is space. So, why is uranium and plutonium radioactive? Well, because the photons within uranium and plutonium are so large, they're so unstable, that they're relatively easy to pop, okay? And they're also large enough in the information spectrum that they're basically shooting out gamma waves every which direction, which is why they're radioactive. Okay? But that's all it really is just flow of space. Okay? So for instance, think about a basketball whenever you inflate it, okay? So you have a basketball, and you start out, it's kind of uninflated, and then you add air to it, okay? Then after a while, it becomes inflated, okay? That's the same thing that happens with photons, okay? Because the more space that they have within them, the more inflated they are, okay? Like for instance, think about your stove. Whenever you turn your stove on and it turns red hot, why does it do that? Well, because the flow of space, which is basically Higgs bosons, is so strong that it's charging up the photons, which are basically shooting in infinite directions, popping in infinite directions, okay? And that's why it's getting red hot and it's starting to brighten up, okay? Because of that flow of space, okay? That's all it is. It's all just a flow of space, okay? So, whenever they did the double slit experiment, you might have to look that experiment up to know what I'm talking about. But they basically had a screen set up and they watched as particles collected on the screen naturally, okay? And whenever they watched it naturally, the particles collected on the screen in a wave formation, okay? But whenever they went to measure it, it threw them for a loop because they collected in a particle formation, okay? Why did that happen? Well, because, like I said, with the gradiuses of space, you are everywhere. You are literally the universe, okay? Like, you need to understand that. You are literally the universe relative to you. I am the universe relative to me. We are the multiverse relative to us, encompassed within time and existence. Okay? So, basically, with you being everywhere, whenever you start to measure something, whether it's from me to this chair, or whether it's from me to a galaxy that's 90 billion light years away, it doesn't make a difference because relative to me, I'm everywhere. So it's going to be just like the same thing as measuring something from me to this chair, okay? For instance, whenever LIGO was able to see the gravitational waves and basically say that they were the same speed as light, well, what's the reason for that for? Well, it's because that's a measurement and you're everywhere. So if you're everywhere, it doesn't make a difference, okay? Because relativity kicks in. And measurements with relativity are a lot of the time you should just negate the information because it doesn't really matter because it's not occurring naturally, okay? Because naturally things are both particles and waves, okay? Whenever you account for just particles, things are finite. Whenever you account for just waves, things are finite. Whenever you account for particles and waves, they're infinite, okay? Which is everything. Infinite waves and infinite particles. Okay? So, let's get into alcohol and drugs. Okay? So, why is it whenever you drink alcohol that you become inebriated? Well, my theory relating to that is due to the fact of the different fields of time. Okay? So, alcohol is made with the use of yeast. Okay? So, yeast is basically a single-celled organism. Okay? And whenever you're drinking alcohol, whenever they make alcohol, they use carbohydrates, yeast, and water. Okay? So, what happens is the fermentation process with the yeast makes a lot of carbon dioxide and ethanol. What is the carbon dioxide? Well, it's just yeast farts. What is ethanol? It's yeast crap. Okay? So, whenever you're drinking alcohol, all you're doing is just, and you're getting intoxicated, all you're doing is just drinking yeast crap. Okay? But the thing about it is, since yeast is a single-celled organism, their string is moving relatively a lot faster compared to us. Okay? So, whenever your field of energy is basically absorbing that string from that yeast, you're basically absorbing string that's going a lot faster than your string's going. So what happens? Well, all of you compensates for that. By doing what? By slowing down your string. Okay? Because it compensates for that. Alright? There's different fields of time for everything. The fields of time are infinite as well. Okay? And so say you take a hallucinogenic like a mushroom. Well, this is theoretical, but relative to us, plants and fungi that are still connected to the earth are on a relatively much slower field of time than we are. Okay? Entities that are separate from the earth, living beings, are on a much faster field of time than those that are still connected to the earth. Okay? So, whenever you ingest those mushrooms, certain kinds of mushrooms, that string is going so slowly that what happens? Well, your string compensates by making it faster. Okay? And that's why you see all this crazy stuff whenever you're hallucinating. Okay? Because that's all it all is compensation for slower and faster string. Okay? So, let me get into how exactly it works with a photon. Like, for instance, me right now, me and you. Whenever we're looking at this imaginary photon, why is it that we can see the light from the photon, but in between us, we see space? Well, I'll tell you why. It's because the photons that are popping out, shooting out, after they leave this, they get to be so small that they're basically, so like I said before, it goes basically from Higgs boson to a photon to Higgs boson, and it does that infinitely, okay? In infinite directions, okay? So the reason for that is because the photons from this thing are basically popping, okay? And after the photon pops, what does it become? It becomes Higgs bosons, okay? Which is basically the Higgs field, which basically separates everything, okay? The Higgs field is basically the space that's within us and that's outside of us. It separates everything, Okay? It's basically the string infinitely contracting. Okay? And the photons are the string infinitely expanding. Okay? So that's all it basically is the photons are relatively so small to us that they're still coming at us, but we just can't see them, okay? Because they're basically the Higgs field at that point, okay? So, all right. So let's get into some more trippiness, okay? So, like I said before, you have. Okay, I don't know if I'm going to draw this or not, but you have us, which are basically the fundamental particle, which are what? Infinite photons and Higgs bosons, okay? Which make up what? Gluons, okay? So we're basically the fundamental particle that's basically floating around on a gluon, okay? That's revolving around a photon contained within the universal Higgs boson, okay? So what is that? What exactly does that entail, okay? So like I said before, it's a Higgs boson, photon, Higgs boson, photon, Higgs boson, photon, Higgs boson, photon, and that happens infinitely, okay? But what does that mean to our existence, to our universe? What is out there, okay? Well, where it starts to get trippy is our entire universe is basically a Higgs boson contained within a photon, okay? And one day, that photon is going to pop. And what's it going to become after it pops? It's going to become, well, it already is, but it's also going to become infinite photons and infinite Higgs bosons. Okay? But that's all. That's all it is. It's all contained within one Higgs boson contained within a photon. So the next time you think that your life is relatively short, contained within the photons shooting out at me from this board are basically Higgs bosons, which contain what? Our universe. Okay? So relative to us in that gratis, how long we exist for on this gratis is relatively infinite. Okay? Because that's a microcosm of time, how long they exist for. Which is the same thing with us. We're only existing on a microcosm of time relative to somebody else, or relative to you or me in another gratis. Okay? So, you can think of a photon that's infinitely shooting out string as time moving forward, okay? You can think of a Higgs boson that's infinitely contracting string as time moving backward, okay? So, what does that mean? If time moves forward from a photon, but time moves backward in a Higgs boson, what does that mean relative to you and I? Why is that? Well, because time has to go backward in order for us to be able to remember things. Okay? So think about it like this. All the string is being shot out from the photon in every which direction. All string is being pulled in by the Higgs boson in infinite directions. Okay? So you are basically a conglomeration of infinite photons and Higgs bosons. Okay? So, for instance, me right now, my photons are infinitely shooting out string at you right now. Okay? And your Higgs bosons are infinitely pulling in string from me right now. Okay? That's how you're going to remember this video. Okay? But yeah, that's basically all it is. Okay? So photons, string pushing out, Higgs bosons, string pulling in. Time forward with photons, time backward with Higgs bosons. Photons are, you can think of as time travel into the future, okay? Higgs boson to the past. Because of what? Because of memories. And theoretically, if we can develop a spacecraft where we can basically circumvent all the obstacles of traveling to the black hole in the middle of our galaxy, well, theoretically, we'll be able to go back in time, okay? Because mathematically, where you thought the black hole was going to begin, you're never going to catch a black hole. It's just like chasing a rainbow. You're never going to catch it, okay? But once you get to that point where you thought the black hole was going to start, you're going to start seeing stars get smaller. And why are they getting smaller? Because they're getting younger. Because you're traveling back in time. And one of the other obstacles relating to that as well is, I don't know how that will affect us. Because relatively, we might start getting younger, and at the same time we might start getting younger, we might start losing our memories, okay, because we are going back in time. But I don't know for sure how that would affect us for sure. I mean, I could be wrong. Send a bunch of people on a spacecraft to the black hole and they just die. Hopefully that doesn't happen, but anyway, theoretically, you would be traveling back in time, okay? So think about the photon as positive infinity, and the Higgs boson is negative infinity, okay? And in infinite dimensions, what is 0? Well, it's a sphere, so 0 is the same thing as infinity. Okay? So what is the encompassment of everything? Everything that exists. It's time. Time. Time is the encompassment of everything that exists that you could equate to God. Because there's been the philosophical argument of, is God immanent or is God transcendent? Okay? Is God matter, immanent, or antimatter, transcendent? Well, God is both, because time is both. And relative to you, you are the God of your own universe. Okay? That doesn't mean you can't still ask for help and pray and stuff like that, because relative to everybody else, they are all gods of their universes as well. Okay? So there's nothing wrong with praying and saying, Lord, please give me strength, different things like that. Because with synchronicity and things like that, stuff doesn't just happen by chance, okay? Energies basically attract energies, okay? I remember watching a video one time, and there was a girl that used to be with the Westboro Baptist Church, and she basically was just taught hatred and intolerance, and then some guy got a hold of her on Twitter and taught her love and tolerance, and I think they got married, and now she's like a pretty happy person, like the hatred and intolerance was pushed out by the love. You know what I mean? So I'm sure she's a lot happier of a person now, But, is God immanent or transcendent? Well, what does your ego do after you die? It transcends, right? Well, therefore, God is immanent and transcendent. Okay? Both the matter and the antimatter. Okay? So, what is consciousness exactly? Consciousness is basically the flowing of string. Okay? For instance, me right now, I am infinitely absorbing string from photons all around me. Okay? Basically, the photons that are all around me are infinitely being absorbed by my Higgs bosons. Okay? And vice versa for them. I stand in front of this board and I move. Now, you're infinitely absorbing the photons from this board. Now you're infinitely absorbing the photons from me. Okay? Consciousness is everything. It's basically just a flow of consciousness. Okay? Even if you're walking down the sidewalk and walking by people, it's still a flow of consciousness because you're still seeing their stream. Okay? It's all consciousness. Because you are the universe relative to you. Okay? It's all just a big stream of consciousness. Okay? And it's so infinite, it's ridiculous. I mean, I've delved into this stuff, and it is so beautiful. Existence is so beautiful. Whenever you delve into it like I have, and I don't think anybody's ever delved into it this far, it is so beautiful, Basically just a series of spheres getting infinitely smaller, infinitely larger, going every which direction. It's beautiful. And the thing about it is, what's pushing out everything? Love. Love waves. You are infinitely absorbing love from every which direction right now. It's beautiful. It's completely beautiful, And in an infinite existence, we can't build it from the beginning. All we can do is reverse engineer it. Okay? So that's what I'm trying to do right now. Because I've awakened to realize that I am God. And I'm here to try to get you to understand that so are you. So is everything. Both the immanent and transcendent. It's beautiful. You know what I mean? I mean, now that we know this information, we can pretty much do what we want to do. You know what I mean? There's no limits. We can go as fast, as slow. We can do whatever we want to do now because we know this information. Okay? But, you know, you are everywhere. You're infinite. Okay? Relative to you, this lifetime is finite. Okay? Because mass is limited. But energy is infinite. Okay? And like I said before, energy equals matter. So, you right now, this is the only time you're going to exist as you are. Okay? But the next time, but whenever your ego transcends and you become something else, you're going to be something else. Okay? It might be the same, your energy, but you're going to be something else. You're going to know nothing of this life. You're going to be completely different. Okay? But you're going to be something. Okay? Because all it is a series of spheres getting infinitely smaller, infinitely larger. Higgs bosons turning into photons, turning in the Higgs bosons, turning into photons, Higgs bosons, photons, infinitely. Okay? That's all it is. But it's all infinite. And it's beautiful. It's incredible. So, anyway, that's pretty much it. You know, if people have issues with this, with me saying things like you are God and I am God, all this basically relates to the religious teachings as well as the scientific teachings. Okay? They're all coming together now with basically us reverse engineering the string. Okay? Nobody was completely right. Nobody was completely wrong. Okay? It's time that we awaken and we come to a point where we all care for one another. Okay? Like with Scientology, they use the machines for going clear and stuff like that. You don't have to do that. All you have to do is forgive your past transgressions as well as other people's past transgressions. Forgive others as well as yourself. And become an infinite conduit of love that we all have the capability of being. Okay? It's that simple. It's easy. Okay? So, yeah. That's pretty much it. That's about all I had to talk about. If you have any questions or anything like that, just ask in the comments. Like I said, it's always ever evolving. Okay? So something I say today might not be something I say in a month from now or a year from now. Okay? It's always ever evolving. Okay? There's always entropy. Okay? You can respect tradition, but if you grasp and hold on to the hierarchy, it's not going to do any good for you. Okay? You have to always be open to change. Okay? So that's pretty much it. Respect science, respect religion, be kind to one another, practice love and tolerance. Don't practice hate and intolerance because that doesn't do anybody any good. So, all right, well, I can mention my GoFundMe page. It's Magnitis Toys, MAGNITIS Toys, if you want to contribute to that. If not, that's fine. I just appreciate your time, and I thank you, and have a good day.